Hi, everybody. Welcome to this special CUBE conversation. I'm excited to have two great guests here today. Joseph Santamaria, who's the Global Director for Solutions Architecture and Customer Success for the Energy and Utilities business at AWS, and Jim Brady, who's the Chief Digital Officer for the Oil Field Services and Equipment division at Baker Hughes. Baker Hughes is a global energy company. Many in our audience may not know them, but they serve the oil and gas industry, and the company, they span the entire energy value chain. So we're going to really dig into that. Oil field services, drilling equipment, they build tech like gas and steam turbines, and they're about a $30 billion company in revenues, $50 billion market cap, and a balance sheet that you would drool over. Gentlemen, welcome to theCUBE. Thanks so much for spending some time with me.
Yeah.
Okay, let's set the stage here, Jim. When we talk about agentic AI, it's all the buzz. I'm just back from the supercomputing show, and it's all anybody was talking about. But how does it relate to upstream energy operations, something you and I have talked about previously? What does that really mean in practice? How do you define that?
Yeah, so I'd probably take a bit narrower definition than some of the people in the industry. I think you're right. There's a certain hype factor. I think a lot of people are calling a lot of things agentic. What I like to call agentic is the more formal narrow, which is if you have an LLM, which you've built, you've probably enhanced an existing LLM that has a certain amount of information access. An agentic AI, by definition, uses that repository and that ability to query that knowledge to take then some sort of automated action. So I very much bring it up through the narrow Gen AI approach. I think the other question, though, is why is this important in upstream? And we'll touch on this, I think, a lot throughout the next minutes, but primarily it's to deal with complexity, the complexity of what we have to do in the industry with increased demand, more difficult hydrocarbons to access and deliver, has a lot to do with human capital extension, right? Being able to give more powerful tools to the practitioners within this industry. And then finally, it's regulated a bit by control. So I think that's sort of the why of things. That it's so interesting right now. It's to deal with the complexity issue with fewer people and harder to get reserves.
Yeah, thank you for that, Jim. And Joseph, thinking about, I mean, your observation space is the entire sector. And what Jim was just talking about, essentially, to me, is you've been able to now to scale without just adding more labor. You can get better operating leverage. But Gen AI has been, the real buzzword and making waves across the industry. It is somewhat complicated, but what makes it particularly well suited for the difficulties and challenges in oil field services and things like energy production?
Yes. Hi, Dave. First of all, thanks for having us here. It was a pleasure being here. Yeah, Gen AI, generative AI is really exceptionally well suited to tackle the unique challenges of oil field services and energy production in general. I'd highlight for two reasons. One is has a tremendous ability to synthesize massive complex data sets and like those generated by field operations. Beyond that, it's also very good at adapting to changing conditions, right? Which is usually the case in the field. There are a bunch of data streams that change. Gen AI and agentic agents can have some level of agency where they can adapt through to those variable conditions. That allows energy companies to optimize operations, enhance safety, sustainability across upstream, midstream, and downstream activities. Let me give you a couple examples of what we see customers doing. One, for instance, is we have customers who are generating synthetic subsurface data to reduce drilling uncertainty. Others are optimizing uplift and chemical selection using Gen AI directly during production operations, or even forecasting water encroachment and sand production to minimize field disruptions. But even beyond field operations, we're working with many customers in trading, supply chain, retail, to name a few areas. Gen AI really has applicability in virtually every facet of oil and gas operations.
We love to talk about the tech, the AI, the LLMs, the agentic, and all the sort of details around that. But at the end of the day, it's about delivering value for customers. And we have a premise at the Cube Research that increasingly organizations are going to use their proprietary data. They're going to build architectures, and they're going to deliver value to customers on top of those architectures. So I want to sort of zoom in on the innovation strategy, Jim, that you guys are using. Leucipa, or Lucy, if I can call it that, is a cloud-based software platform that you're using to automate field production for oil and gas assets. AI workflows, you're simplifying things, as you suggested earlier, sort of augmenting the human. You've got machine learning in there. You've got physical models all sort of tied up in there. Can you share details on Lucy, what the strategic vision is behind embedding AI into the architecture, and what are you aiming to deliver to customers?
Yeah, so good. So yeah, let me go through a little bit of that. I guess obviously production software has been around for a long time. What we did was about 5 years ago, we did a research into where we thought the industry was going, where complexity was going, and where the needs of the operators were going. We anticipated that the bulk of energy demand would need to come from already known producing assets. In fact, by 2030, about 80% of the oil and gas that we have to recover from are already known reserves that are in decline, right? We also observed that there really wasn't anything quite that brought together all of the disciplines within production engineering, which has to do with kind of decline rates within wells. It deals with scenario modeling at the field level. It deals with power issues, emissions issues increasingly. So when we went about to make Leucipa, which is the base platform, if you will, we said we need to design it with primarily three things in mind, right? One is it needs to be automation ready, which means that you need to be able to rapidly do scenario modeling, updates. Everything had to be in autonomous workflow, still in control and kicked off by a user, but you had to have that end-to-end automation. Second was it had to be able to connect to data. As either Joseph or yourself pointed out, oil and gas is notorious. There's all sorts of data. There's homegrown data. There's product data from other vendors. There's equipment from everywhere, all involved. So when you go into the production world, you end up dealing with dozens of different data stores. And by definition, you deal with equipment from various vintages from many different vendors. And so we said Leucipa had to be able to connect and integrate across all vendors and all data stores. So Leucipa ends up having, I think, is like 90 different connections, right, to different data applications. We can work with our own, oil field equipment, our competitors' equipment, et cetera. But probably most importantly, you had to have the subject matter expertise, the domain basic capability already built in before you start doing all the cute AI stuff, right? And so we have all the basics of classic production engineering workflows, right? It's already in Leucipa. To that, we said it's on that platform that you then add AI. And I like to say we have basically 5 types of AI. Some are more classic, dealing with pattern recognition, machine learning that allow you to understand, when coupled with physics, the failure predictions for different pieces of subsurface equipment, like an ESP. It's a combination always of the physics of how the equipment operates, how the earth operates. And so we can build effectively digital twins of a piece of equipment, different type of digital twin of the actual producing reservoir. And then up top, I say number 3 is just scenario. When you look at wells that have thousands, or fields that have thousands of wells, you end up with failures that aren't possible to always anticipate. And so you can very easily get into these non-optimal reaction modes. So level 3, if you will, is scenario optimization. So what if this happens? What if these happen? What if there's a power constraint? What if these parts of the equipment fail? What if all of this, trying to reason with huge combinatorics of the problem. On top of that, I call type 4 is that conversational, which is exactly what you guys were talking about. Bringing together all of this data from wells, from fields, from power sources, from surface equipment, all that, and just from dozens of different data stores, bringing it together, creating an LLM that you can much easier query. So you can say, hey, Lucy, and Lucy, if you will, is the agent that lives on top of Leucipa. Yes, there's some intentionality in that name, right? So you say, hey, Lucy, which wells do I need to worry about in the next 36 hours? Hey, Lucy, how is my acid frac going compared to the ones I did in this other field? Hey, Lucy, right? So it's that conversational query as opposed to click, 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 filter, zoom, zoom, all that, right? So again, it's that human capital center. And then level 5 is the agentic. So instead of coming in the morning and saying, hey, Lucy, what do I need to worry about today? You come in the morning and Lucy says, good morning, Jim. While you were out, I noticed that there was a bit of water coning that you did not anticipate, Jim. So I took the following precautions on your behalf. Is this okay, Jim? Right? So it's that proactivity on top of the information that you have to query from, right? You combine those things, the elements of data, the elements of automation built in, all of the core production engineering capability, you add AI equal sign Leucipa. And that really was the strategic vision that we laid out a few years ago. And we've been building it, we've been deploying it. It's all over the world right now, and it's growing. Did we anticipate the Gen AI as it, 5 years ago? No, to be honest, no. However, it so easily fit into the framework that we were building that it was a natural extension. And, given the agile development, we were able to sort of retool some of our priorities and plans, engage our customers, and to bring that in.
So thank you for that. So a couple of things. Lucy doesn't sleep. I love that. And even though you didn't anticipate the Gen AI wave, the key was you had your data act together, connecting and harmonizing all that data. I think that when you hear sort of the MIT study, of course, is getting a lot of attention in the industry. 95% of their 50 sample users aren't seeing a tangible ROI at scale. But when you talk to those users that aren't getting ROI, what they tell you is, well, we kind of under anticipated the difficulty of getting our data act together. And the other point you made about domain expertise sort of being embedded into the model. So that's a sort of interesting and instructive information in terms of kind of best practice. Start with the data and the domain expertise, and then and only then, of course, the governance, and then and only then add in sort of the AI component, the intelligence component. So for each of you, and maybe Joseph, you could start, if you look ahead, the next 3 to 5 years, what role do you see intelligent agents playing specifically in energy operations and maybe even more broadly in the industries?
Yeah, I think Jim covered it, beautifully. The role of intelligent agents is going to expand progressively, but also rapidly, right? And it's transitioning from what's happening today, where these agents are collaborating or augmenting humans by automating specialized tasks. Jim just mentioned a few examples here. From either trading reports or producing specialized safety briefings in the field that operators can take, that are contextual, that are based on actual pump operations or asset operations. But over time, this will shift towards more end-to-end, autonomous, proactive. I love the Lucy example where doesn't sleep, wakes up in the morning, tells you what's going on. So it starts to take agency and taking ownership for coordinating a little more complex workflows, right? And that coordination will start being deterministic and with many humans in the loop, as you would expect at the beginning. But as models improve and learn, I anticipate progressively they'll be given more agency to complete end-to-end tasks autonomously. With agents eventually probably coordinating swarms of other agents. We have customers who are experimenting with that right now in research and development, for instance, where you have a research agent, an engineering agent, a science agent that are orchestrated in trying hundreds, thousands, millions of combinations and simulations to really improve whether it's methane pyrolysis or different aspects of field operations. Yeah, so these agents will collaborate, each of them handling specialized operations, whether it's coordinating repairs, suggesting process adjustments, as Jim mentioned, flying compliance risks. As a matter of fact, we recently, Deloitte and Gartner ran independent studies and came to similar projections that by 2027, about half of the enterprises will be adopting generative AI at agentic level with intelligent agents. Deloitte came up to that 50% of companies will be using agentic AI by 2027, and actually Gartner is anticipating that about 50% of all business decisions by 2027 will be either augmented or automated with agents. And I have to say, I think at times I wonder whether that's conservative. We're seeing, virtually every one of our customers embedding agents into their operations at this point.
Yes, and of course, coding is the killer use case. Everybody's getting real tangible value out of coding, but it's been harder to find those other use cases. This is a really good example, and I'm curious as to maybe some of the learnings, Jim, and maybe misconceptions around Gen AI, particularly in industrial settings where, okay, you've got hallucinations, you've got probabilistic AI, and an industrial setting, that's very dangerous. You have to be, certain. So what are some of the things that you found, and are there misconceptions that people have that you've found that you've been able to address with regard to Gen AI?
Yeah, so that's a good question. So I think the first thing is kind of go back to what I was saying earlier. I think when you go back to the MIT study, right, you realize that the 95% failures or whatever it is, right, they usually lacked a foundational precondition for what they were trying to do, and very often it's data support. And so I think for everything that we're trying to do, we fundamentally have to ask the questions of, do we have the data support to do AI or agentic AI here? We don't have to understand it deterministically, but you have to have a notion, is there data support and is there enough process support to be able to implement this, right? The other, though, that we've focused a lot on is the actual software development process. So the RAGAS process is what we happen to use, which is, I think, it's almost like data science. Probably 10 years ago, you put a couple people in a closet with some Python or R, and then they're just supposed to crank out failure prediction, capability for equipment, and that was sort of the development cycle. And then we got a lot more mature with, model life cycle, et cetera. We're going through the same thing with Gen AI. We're using a process. Part of that process is guardrails. It's test validation. I just spent last week a full day with my team that's doing the Gen AI development of Lucy and understanding how we actually do automated testing, coverage testing, guardrail testing. We have to test in multiple languages, right? One of the powers of Gen AI is that people can ask questions in their own native language, which in oil and gas is extremely important. We need to be able to have an operator who may not know English be able to ask Lucy, if you will, or whatever the Arabic name for Lucy is, the question in their own language, and then Lucy will respond, of course, in Arabic, right? And so there's a certain amount of testing that you have to do to make sure that you don't have language translation problems, especially when we're out, with our own sort of lexicon and in the industry. IX, right? When we design these systems, we still have to have IX in mind, which is, security for control systems, and make sure that you're not, accidentally or purposefully overloading or overruling a lot of the controls that you have in place on your equipment. Security goes into that as well. To follow up from Joseph, I guess where I see a lot of this agentic AI going is, yes, we have our helpers and we're watchers. Yes, we have our recommendations. That's probably, next. Yes, we have controllers according to different levels of safety. But the interesting one is when you start to get to what Joseph closed with, was the agent to agent. And this is not just one Baker Hughes agent on, say, field production talking to the Baker Hughes agent on liquefaction, right, or gas processing, right? That's a controllable thing. This might actually be a Baker Hughes agent that has to ask a question to a competitor's agent. right? It might have to say, hey, I don't know, I'm not gonna say my name, but like Bob, right? Bob, can you tell me something about, the water forecast for this particular well in the next year? The classic field production system doesn't have that. It doesn't operate that time scale, whereas a reservoir simulator might. But there's a presumption that the agent you're asking a question to actually has to have the context to be able to answer that question and then give an aspect of certainty back. So we will have to address the question of trust and the issue of trust between agents. Yes, probably everybody on this call has to know somebody who's doing an MCP protocol to talk agent to agent, but that actually isn't the hard problem. It's the trust problem, especially in our world where, lack of trust or a poor response could cause an action on a piece of equipment that could fail in horrific ways, let's say, right? So I think that's a bit of where we're going, and that I think is going to be the real challenge for the development process is how do we as an industry come together and say, hey, if I ask you, my competitor, these questions, how can I be certain of it without trying to say, I need to do everything my competitor does because I don't trust them. And so all of a sudden, I'm going to have this one massive application, right, that has to have all knowledge, right? I don't think anybody wants to go there. But I won't say that the trust between vendors and suppliers is easier.
Right. Okay. So there's some maturity over the next few years. I wonder if we could get into how you guys are working together with the role AWS plays. I'm interested in the sort of collaboration between Baker Hughes and AWS. Where have you guys focused? What are the innovation priorities that you're really driving to the market? Joseph, I wonder if you could start, and then let's hear from the customer.
Yeah, thanks. Yeah, from the very beginning, we looked at our collaboration and partnership as very strategic. We wanted to go far beyond supplier vendor relationships. We saw collectively and together an opportunity to disrupt the industry in this production space because we realized we both brought and separately and jointly brought very specific and unique capabilities to the partnership, right? So, for instance, Baker brings decades of oil field expertise, a global presence, and deep customer relationships in the industry, and they lean on us not to just for cloud infrastructure and the breadth of our services, which are the broadest and most comprehensive of any cloud provider, but also for our advisory support in helping them really architect high performance, scalable solutions that take advantage of the latest cloud capabilities. Jim already mentioned Agile, how they're working Agile development, and that allows their internal Agile practices, our cloud capabilities, and the native services allowed them to maintain technical leadership and to incorporate the latest technologies to deliver customer value. An example that also already came up of how this flexibility and speed can become an advantage was that when we signed our strategic collaboration agreement with Baker to partner on Leucipa, GenAI was really not in the picture quite yet, and certainly not in any solution roadmap. And as of now, we're working together, and nearly every roadmap feature that we're building either directly leverages and incorporates GenAI or is quite closely tied with it. So and aligning on these innovation priorities involves a natural back and forth with Baker, where we lay out the art of the possible from a tech perspective, and Baker Hughes acts as the voice of the customer and brings the latest, needs, pain points, opportunities in the industry. So this push-pull, helps us land in somewhere that is optimal and at the same time practical. And it's a huge strength in delivering effective solutions for our joint customers.
I wonder, Jim, if you could chime in this context. When I think about things that you're doing in the field, and I think of like an edge sort of use case, and then I think cloud, and I say, okay, well, how do those two go together? Like, how did you decide to go cloud native? How do you scale obviously with cloud, but at the same time, you've got the latency issues and you want to speed to market and so forth. So how does that all work from your standpoint Jim. And then Joseph, I wonder if you could give us a broader brush of the industry.
Yeah, so that's actually a really good question. I mean, it'd be nice to say we were cloud native and all that. The reality is we have a more complicated architecture, as you hinted at, right? um, some of that's driven by our customers' own security concerns. A lot like to keep certain amounts of data within their own corporate networks, and there's cost and, as you said, bandwidth or latency issues in trying to move everything to cloud. So we end up with, I'll say, a hybrid architecture where there's certain things that happen at the edge, and those things tend to be more control loop in nature. Things like, perhaps an automated chemical injection, or perhaps just making sure an ESP doesn't get out of a proper operating range. So very tight edge loops, right? That's not going to be in the cloud because of the control nature of it. There's a certain element of Leucipa, its core, that can be within a corporate network, if that's what the customer prefers. Sometimes it has to be that way, because of certain data residency requirements. The big area where AWS helped us with is part of that architecture, but then also how you then scale. And so while we can do certain, I guess if you call the basics or fundamentals of production engineering on even an on-premise application, once you start getting into the machine learning, we leverage SageMaker. For the Gen AI, it's Bedrock, and those are right now cloud services, right? And as AWS starts to bring those cloud services, in many different countries and whatnot, the elements will probably come closer together. But yes, it's cloud native certainly on all of the AI stuff, but there is a flexibility of deployment that ends up being dictated by our customers. Can we operate it all in cloud? Yes, but we don't make that decision. It's actually our customers, and we have customers in 85 countries in the world, right? And we have many customers with many different demands and preferences.
That makes sense. And I wonder if I could follow up on that just in terms of, so you've got, a lot of, legacy infrastructure. I'm sure there's some technical debt there as well. You're bringing Gen AI and Agentic into these systems, which is non-trivial. And again, Joseph, would love your thoughts on this, but I'd love to hear from Jim first. What were some of the technical hurdles that you encountered and you had to overcome? And then Joseph, I'd love to hear what you're seeing across the broader industry.
Yeah, I think the biggest was actually dealing with the hybrid architecture. And I'll say that wasn't necessarily a obsolescence issue. It was just a technical architecture, which is how do you develop an application which leverages some things in the cloud and some things that can be on-prem or in the cloud, right? So there was a very strong design element. The other challenge, and again, I'm not even going to say this is a legacy code because, quite frankly, Leucipa isn't really legacy code. It's all fairly modern. We're not dealing with some application that was built, circa 1998 to 2010, and then trying to, ram these things into it, right? It's much more recent than that. So we had the luxury, if you will, of having automation, data connectivity, and some of these things built in. It was the complexity of the architecture that we had to deal with primarily.
That makes sense. And Joseph, you got to live in that world. It's not always beautiful and smooth and greenfield. How do you see the challenges playing out?
Well, when customers come to us, there's many reasons for that for them to do that, but typically it comes because they're trying to reduce costs, they're trying to scale, or they're trying to move faster. When it comes to deploying AI and just general digital solutions in the field or in the enterprise, and there are many ways where cloud native platforms like AWS are enabling that scalability, speed, and cost reductions when deploying solutions from an infrastructure scalability perspective. For instance, we offer elastic compute resources by providing on-demand access to specialized AI infrastructure, including from GPUs from NVIDIA and others to our own chipsets, Trainium and AWS Inferentia that offer leading price performance, which allows energy companies to scale computer resources dynamically based on their variable workload demands. And they can do that obviously without any upfront capital investments and have a pay as you use and don't pay for what you don't use because you had to over provision and over dimension your environment. But there also have many customers who don't even want to deal with infrastructure, and for those we offer a number of managed services platforms if they want to operate higher in the stack. Two good examples, Jim mentioned already Bedrock. We have Amazon Bedrock and Amazon SageMaker, which eliminate the need to manage any underlying infrastructure and enable our customers to focus on building and deploying AI applications rather than doing this undifferentiated work, maintaining servers, and just dealing with core infrastructure. And that reduces their time to deployment and lowers their cost. And then from a speed advantage, right? If you think about we have reference architectures, cloud native architectures that have been implemented, capture patterns that can be deployed through partners or directly by customers, which also reduce the time to value and the ability to maintain architectural consistency and best practices through proven solution guidances that we provide. Obviously, another advantage of the cloud, and it came up already today with the Gen AI conversation around Leucipa, is continuous innovation. Right, we have access from talking particularly in the Gen AI space. We provide access to our customers to leading foundational models and agentic platforms like Agent Core, where we are continuously updating with the latest technology without requiring any infrastructure upgrades on our customer sides. That allows our customers like Baker to adopt the latest AI capabilities immediately, and they like to do that with unified control planes, right? Modern cloud-native inference systems offer agentic, LLM-specific auto-scaling, intelligent request routing, fault tolerance, production-grade, modular, and scalable AI deployments that can be all coordinated and orchestrated from a single plane. So this combination of elastic infrastructure, managed services, and industry-specific solutions enable our customers to deploy AI solutions in field operations in weeks rather than in months, while scaling seamlessly across the world, meeting whether it's residency requirements or the variability of field and production operations in a very flexible manner.
Well, thank you for that. And the optionality that you have in the cloud, generally at AWS cloud specifically, in terms of tools, optionality, and ISVs and the marketplace is unmatched. But I want to have the governance and security conversation because I remember early days of cloud, people say, oh, it's not secure, I'm not going to put my data in the cloud. And of course, the CIA deal was a seminal moment in the cloud. People say, oh, this is good enough for the CIA. Maybe it is better security. And I think there's little question that the security in the cloud is better, but sometimes it's just different and you have to accommodate that. And there are corporate edicts. And so I'm curious, maybe we could start with Jim. As you have all this data flowing through the system and you've got these agents, taking actions, how do you ensure security and governance when you're scaling and moving as fast as you are, and you're dealing also with this hybrid infrastructure?
Yeah, not easy, not easy, I'll say, right? Again, part of it is actually it's helped by the hybrid architecture and separating the things that must be on the cloud and the interface between the cloud and especially internal control networks. Obviously, some of the most sensitive networks out there in the industry are rig control systems, vessel control systems, even like well control systems at the wellhead, right? And so that's what we have a lot with IX and certain sort of security protocols around critical equipment and infrastructure. And it's very important that those actually take precedence over what we'd perhaps like to do, right? Especially when you're going from cloud down. And there's ways to do this, right? It's just you have to design that properly. And with some of our friends at AWS, we helped better understand how you do that secure, acceptable way to go from cloud two two internal networks, right? People's control networks are not in the cloud, right? And so we did have to go through some things there. I already mentioned the agent to agent. We obviously haven't tackled that. I think AWS is helping us a lot on, MCP and a lot of this agent to agent. But as I said, some of the hard problems aren't there yet. We're going to have to resolve this out at governance. The good thing, I think, is that Baker Hughes doesn't have to crack this alone. And, to go with Joseph, we were able to move fast because of the partnership. We like to think that we know energy technology pretty well, and I'll say we do. And were we smart enough people to eventually do all this stuff ourselves? Yeah, probably. We would have been about 10 years late to the market. But so we know that for certain things like governance and security protocols around agent to agent, things like that, and how to design a secure network from cloud to on-prem, our collaboration with AWS helps us go fast, right? And a lot of the relationship mandate, if you will, between the two companies is speed to value, right? And so, we leverage what AWS can do. We actually trust that they're going to be providing the things that we will need next year. We don't sometimes even know what those are, but that's an area that we don't have to work ourselves. We can rely on the collaboration. I think again, some of the nuances of security will be in that, but especially within our industry where lives or catastrophic damage is always a possibility. We tend to put security first, and if that makes us go slow sometimes or look like we're not adapting things, that's unfortunate. But that is our precedence again, especially when it touches control systems.
Well, and if you design it in from the beginning, it actually can be an accelerant to getting products and services to market. And Joseph, I've been to every Reinforce, so the security conference. So I've had the Kool-Aid injection, since many, many years. And the thing about AWS security is it's really about the ecosystem. It's not a direct competitor with a lot of the security companies, and so you provide base level services like Security Lake that everybody can take advantage of, but then there's a whole ecosystem around it, so that enhances optionality, and I think it's maybe less confusing for customers. But Joseph, anything you'd add to the security and governance conversation?
Yeah, this is a very important question, right? At AWS, security is priority zero, is job zero, as we say, and it comes before every feature and every launch, including everything we do with agents and generative AI. And when we deal with energy and critical infrastructure providers like Jim and Baker do every day, then it's even more important, right? If that's even possible. But we operate under a shared responsibility model where AWS is accountable for securing the cloud infrastructure, and we give customers prescriptive patterns, controls, tools, automation, and help so they can secure their data, identities, and applications that run on top of our cloud. And that's critical in AI, right? Because building secure AI agents for enterprise deployment presents unique identity and access management challenges that many times traditional applications and security models around traditional applications weren't designed to handle. So I'll give you a couple of examples. One, for instance, inbound authentication, right? Who can access the agent? If you have an agentic capability, when users or applications invoke that agent, you need to verify their identity and determine that they're really authorized to do that, right? And that follows multiple patterns like user authentication, verifying the human can really access that agent, service authentication, validating that other agents in the agent-to-agent collaboration that Jim was referring to. You have to make sure that authentication happens the right way, and that those agents are really isolated from a multi-tenant perspective when they need to be. Sometimes they need to share memory, sometimes they don't. So you have to be able to manage that. From the reverse is also true, right? What can the access, not only who can access the agent, but what's the outbound authentication? So what can the agent access? And agents will need to interact with many resources and tools to accomplish the tasks that they've been tasked with. And that also presents its own challenges, from whether it's acting on behalf of users, service to service authentication, token management to securely store and manage OAuth access tokens, API keys, and other credentials without exposing them to threats. So enterprise, I would also like to mention enterprise integration requirements, for instance. So companies like Baker have invested heavily in identity infrastructure, and AI agents must integrate seamlessly with that, whether it's with Amazon Cognito, Okta, or Microsoft Entra ID, which used to be Azure Active Directory. We need to support, and we support multiple standard protocols like OAuth 2.0, OpenID Connect, and other access. And then finally, from a compliance and auditability, right? If you think about a world where we have dozens of agents doing things, you need to have very comprehensive audit trails where you can access, what happened, when did it happen, why did it happen, how did the agent reach the conclusions it reached. All that transparency and logging from an audit perspective so it can be traced is critical. So without really a purpose-built solution, developers spend months building custom authentication systems and trying to sort these problems themselves. As Jim already said, I mean, they're very smart. They could eventually get there. But what we do is we provide them the tools to do it out of the box. And as such, we have released this year Agent Core, which is our agentic development platform and development agentic operations. And it includes an identity module, identity capability that helps our customers address these challenges by providing a centralized capability to manage these agent identities as an agent identity directory, to create, manage, organize agents and govern them, as an agent authorizer that validates whether a user or service is allowed to invoke that agent. It has a provider for resource credentials to store and configure that agent credentials, a token vault. So it has all the everything that you would need to really manage, create, develop, and operate agentic workflows in a controlled and secure manner.
Excellent. In fact, in a few hours, I'm on an Agent Core pre-briefing for reInvent, but I want to bring it out to the field. I hosted a CDO panel of about 20 CDOs. They were mostly chief data officers, but there were some chief dig officers there. It was at a Snowflake event, and two-way person, a human in the loop. Anytime we talked about agents, a human in the loop, had to have human in the loop. And I see in my notes and prepping for this, you have this exception-based monitoring agents, and I presume that's in the field. I'm interested in what that is. I'm also interested, we talked earlier about the next 3 to 5 years of agentic. I'm interested in, will the agents learn from the reasoning traces of humans? I mean, I'm making an assumption that exception-based monitoring has a human in the loop, but what is exception-based monitoring, Jim? How does it work in the field? How has it been implemented? I think you've got a customer for this service. Can you explain?
So we've actually deployed it to a couple customers already. In fact, I mean, we'll say that we've talked a lot about the partnership of AWS and Baker Hughes for good reasons, right? But the other strong partnership that we have is with our clients, right? And so we have an AI collaboration with Repsol that's quite out there, and there's some others, right? Because ultimately you're going on a journey with them, right? And so they also have to get their trust levels up. The exception-based monitoring, whatever we call it, I just call it the watchers, is kind of an interesting first agent that we did. So what it basically says is when you go and do a particular operation, whether that's workover, whether that's you refract, you did something, changed settings on an ESP, you inevitably did this for some reason. And in a classic world, you would say, hey, yeah, I'm going to create now a little dashboard, and I'm going to look and see how that operation is doing. And then, hey, I'm also going to see how it did relative to the other similar operations and parts of the field, right? And again, it sort of gets into this whole thing that when you have 1,000 wells, is the guy's going to come in or the girl's going to come in the morning, and all they're going to do is look at all these custom dashboards, right? So the idea of the exception-based monitoring or the watchers, as we internally call them, is it's flexible, and you just create a watcher that or exception-based monitoring that says, hey, I want you to, I've done these operations, and I just want you to get back to me and tell me if this well after this particular operation is not performing as per the goals that I initially set, or if it's performing better, significantly better, or worse than similar operations, especially in parts of the field, right? And so these agents are, if you will, running in the background. They relieve you having to do this yourself, and yet you get the information feedback on performance. And so, yes, the things can eventually learn, but they're the classic helpers, right? They can go out, and we're using this on the field that we help out with some of the operations down in Mexico, where we've implemented it just that for certain classes of operations. Again, I think I forget if it was you, David, or Joseph was talking about the manpower issue, right? The challenges we have, you can't just throw a whole bunch of people at, right? So you're not going to throw a bunch of people to watch and monitor these things. It's a classic thing of, hey, can we use Gen AI? It can learn what good looks like. It can learn if this new one is doing as well as the old ones. It can update the standards for how well it should be doing, right? So that I guess in a nutshell is that application. And yes, we've applied that to a few different customers, from kind of gas monitoring or gas well monitoring for marginal fields to basic workover operations in conventional land, oil, and there's a couple things that I really can't talk about yet.
Great, thank you. So Joseph, I wonder if we could bring this to business value. Do you have an example of where sort of injecting AI into the system has driven real improvements in the field? Whether it's field engineers, operators, how are they responding, and how are they getting value out of these changing workflows? I'm curious as to how they're responding to that. Are they afraid they're going to lose their jobs? Are they, going through a cultural, renaissance? Is there training involved? What are you seeing in the industry?
Yeah, well, we're clearly seeing we're at an inflection point where adoption of AI is exponentially growing, and we see that in the number of applications, consumption we see of our services, and there are plenty of examples across the industry. You wanted me to give you a couple. One comes to mind. Actually, you mentioned reInvent. So last year on stage with us was ExxonMobil, and they talked about their experience using Leucipa and the SageMaker recommendation engine that supports it around failure prediction of electrical submersible pumps. And they quoted a 10x ROI. They have it deployed to dozens of wells and have dozens of users. What it helps them do is identify problems in wells, determine the root cause, and then recommends an action. They, increasing the run life of an ESP by 10% would generate for them up to $50 million a year in value when deployed at scale. So that's an area they're pretty satisfied with, and it's a great example. Another example, I'm not going to mention the customer here, but it's another large operator. They use a Gen AI application that we built with them, with again dozens of users. They do 25,000 voice-enabled AI interactions a month with a Gen AI system that is being embraced by the operators. It's trained in their specific data sets, so they're helpful to operators. I mentioned earlier we're working with another customer, for instance, in a number of customers on safety. And what we're seeing is, the information receive is much more valuable for them. Like in the safety space, they get, before they go out and do a job, they get information that is contextualized with weather patterns, asset conditions, and near misses in that type of repair or in that location. So it provides, safety briefings that the operators really want to read because they find them useful. So we're seeing, obviously, every change brings concerns, but we're seeing customers really embrace the technology because it can deliver, and it's delivering already, real value for them.
Yeah, thank you for that. My last question, Jim, is again staying with business value. How do you measure success? What does this look like? The success for AI in upstream energy. How do you think about the impact when you look a year, 2 years, 3 years down the road? What does success look like?
Yeah, I'll say at the broadest level, It's, will the industry be able to provide energy according to the world's demand in keeping cost flat? I say if we as an industry can do that, we've effectively done our job for the world, right? And it's interesting that you say, well, that's just so macro, but when you actually get down to all of the AI implementations we're doing, each and every one of them start out with a proof of value or proof of concept, whether that's major resource holders in the Middle East, Western operators of gas, or even, land conventional oil, offshore, et cetera, right? They all start out with this proof of value. And so, if you will, we have to earn the right to show value to even get in. The Exxon case was one example. Even though we're strong partners with Repsol, we still have to do that proof of value for each AI that we implement. And there's a number of others, right? And at the end, they all deal with that duality of, we need to be able to increase production in a much tougher environment, and it needs to be cost efficient because the world needs, needs low cost, abundant energy. We've been talking a lot about doing that within, production, field production. Within Baker Hughes, we obviously operate across the value chain, and so we do that same process, proof of value, deployment, and energy optimization, which means more value, or more energy, more joules delivered at ideally flat or lower cost. We do that with topside gas processing. We do that with adjacents like a fertilizer processing, which is, obviously a plant derivative. We do that with turbine and compression efficiency. All of these things, we have to go through that basic process of showing its value. And so by the time that, we get adopted, if you will, within a customer, I'd say we passed, if you will, that 5% MIT threshold, right? There's a certain amount of success that I won't say is guaranteed, but is more certain. I'll also say, go back to the reInvent the Exxon, we're optimizing everybody's ESPs. It's not just, again, ours, right? And so again, part of that is you have to solve the customer's entire problem. You can't just go in and say, hey, we're going to use AI to solve the Baker Hughes part of your problems, right? And I think that's a key thing for success, is AI technology has to work globally on behalf of a customer. It can't just be limited to its own stuff.
Well, gentlemen, this was amazing. We usually go in the cube 15, 20 minutes. So this is almost an hour and a fantastic conversation, almost like a full webinar. I can't thank you enough for your time, and congratulations on your success, and wishing you the best in the next several years and beyond.
Thank you.
So this is a great example. I think mid last decade, I don't know who said it, but they said every company is a software company. That actually really didn't happen, but now we're seeing it. This is an example of Baker Hughes building an architecture, software-like economics coming to their industry and scaling without labor. But it's all about business value, and that's what you're seeing here. So thank you very much for watching this special CUBE conversation. This is Dave Vellante, and we'll see you next time.